Okay, be sure and use the pause button. I don't want to get kicked off YouTube for this video being too long. I've split them up, so we're going to cover set notation first. So from the book, again, I always start there. It's a good place to start. A notation for a set that uses a rule to describe the properties of the elements of the set. That's set builder notation or set notation. Well, that just seems so far out there, it's not really making sense to me, but it's stuff you've been doing since elementary school. You have to learn how to read it and how to write it in this class. So, to read it or write it, over on the right, the example is most helpful. So we see over here on the example that it has brackets. Those funky brackets mean the set of. And I apologize, I don't have my stylus. I'm writing terrible. Okay, that means the set of. Then we see this line. That line means such as or such that. Okay, we're learning a whole different language, but it's really not that hard. And then, of course, you know the inequalities. Greater than, less than, greater than or equal to, less than or equal to. And that's what that line underneath means, or equal to. Okay, so application of this, using our example, the set of x, or all x, such that x is greater than 3, well, if we say that one, we would put a dot on our x-axis that is open. Open dot, and then it's greater than 3. That means it's going to go this way on my number line, which is to the right. And that would give us the set of all x such that x is greater than 3. Now, if it were to have x is greater than or equal to 3, that would mean we would close the circle and point it to the right. So here we have some more examples of set builder notation. This time it's not so open-ended where we're just going to the right of the number line or to the left of the number line. This one has the set of all x such as or such that x is greater than any number. So we'll have any number equal to, okay, and such that x is less than another number, so that would be b, and we'll have that one be 5, okay. So the set of x such that, and for our example here, such that 2 is less than x, which is less than 5. That's going to be my example. You can apply it all the other ways, but we're just going to do one example to make it real quick. So if we do this on our number line, that would mean the 2 on our x-axis is open. It's not filled in. And the 5 is also open. And x can be any quantity in between here. Now remember, in the upper level math, it won't be quite as simple. It might be, jumping up and down all over the graph, so they won't always just be simple line graphs. Now here's something new. Down below here, if you look at the set of x such that x and that funky e, that means element or part of. And that funky R, and sometimes it's written more in cursive, that means the real numbers. So if I were to say the set of x such that x is an element of the real numbers, and you Algebra 1 people, Algebra 2 people, Pre-Cal, any class will see this funky E come up weirdly on a test. It just means element of. And some people might want to just kind of put this in parentheses. It doesn't really mean this, but in your brain you might just want to say equals, okay? Because it kind of does mean the same thing. Element of, it equals, it's part of the real numbers. Well, where are the real numbers on our number line? They cover the whole number line and doesn't leave any number out. Okay, so what does that mean for my pre-cal people or anybody else that wants to learn a little bit more about the more difficult way to read a graph using set notation? Well, from the pre-cal exercise 1-6 function practice, I'm going to go over a couple of problems. To do that, I'm going to zoom in on number 1A. And notice that number 1A already has the domain done for us. The domain is everything on the x-axis. Easy enough. So we're going to look from left to right. What's going on with our domain? Well, the set of x such as or such that 0, which is right here, is less than or equal to, and notice that dot's filled in, x, which is less than or equal to 8, which is over here. So I'm only looking left to right. We're not covering interval notation at this time. Now, looking at my range, that's the vertical. The vertical range is going, it goes like this. The set of y, because it's all the y values, such that, and we're going to look up and down. The smallest value for y, and it's closed, which means it's a closed circle, 2 is less than or equal to, and what's the very top one up here? Oh, I see it's 5. So I've got to put a 5 way over here. And what's my variable for the range? Y. And notice the 5 has some closed dots, so that's less than or equal to. And then I close my set. Now, quickly moving on, going to zoom in on C. On C, we can tell that we have if we put it in our calculator, y equals negative 2x squared plus 3. You will see if you go to second graph to the table that there's a few points on here we can actually pick up, and you know me, I'm kind of picky about sketches. It's got to be pretty close, so I'm going to try to on the screen get pretty close to 0, 3 because I know it's right in there at 0, 3. And it's kind of narrow, so I'm going to kind of draw it, and I'm doing the best I can, people. All right, so it's an upside down parabola. And the domain for this set is the set of all x such that x is, oh, and there's that funky e again, an element of, and there's the fancy r, the one that I write like this with the double. They've done it in that fancy cursive. X is an element of all real numbers. So now let's look at the range. The range, people, we've got the set of, that's my bracket, and the range is now up and down. And just a reminder, the domain was left and right. Okay, the range is up and down. So we're going to look up and down at this graph here. The range is all the y's such that, and so over here, I'm going to kind of do some little reminder notation. We would say the smallest y value, if I were to use my pattern from before, my smallest y value, I can see that on this graph. On this graph up here, the y's keep going on to negative infinity. So over here, I'm going to kind of think, okay, it goes from negative infinity, and that is y. And so y is greater than negative infinity. Okay, my infinity sign. And then the largest y can be is up here, which is at that 0, 3. Okay, so largest it can be is 3. And y is less than, and because it touches the 3, it's equal to 3. Well, you might want to think of this, we call this as side work, okay? This is what you kind of have to work at thinking. But higher I go in math, the lazier I appear. I don't have to write near as much stuff. If I know that y is greater than negative infinity, can't I say that the set of all y such that y is less than or equal to 3, and it's just understood that it's less than 3 and it goes on and on to negative infinity? I hope that helps you understand set notation, and if you have any questions, don't hesitate to talk to me.